Hello, hi. In yesterday's video on the challenging question, vectors distance between two planes, I used the concept of cross product to convert the equation of a plane in this format to the r.n format by crossing these two vectors. Okay, so I cross 1, 2, 0 with 0, 4, minus 2. So now I promise that I will show you how to, in exams, because speed is the essence and we want to calculate cross product as fast as we can in the exams. So I promise to show you the quickest way to calculate cross product of vectors. So let me just erase, go to the next slide. I'll just put this as big as possible. 1, 2, 0. Just let me write it bigger. Okay. 1, 2, 0 cross with 0, 4, minus 2. Okay. So this is the I, this is the J, this is the K. Okay, it's like 3 dimension, right? So I, J, K. So when you want to calculate, just remember the result, right, is a I, but the J is a negative, and then K. So when you want to calculate the I, what you do is you first block out the I. Okay, just let me block out the I when you want to calculate the I. Then you use, always slant down first. 2 times minus 2, which is minus 4, negative 4, minus 0 times 4. So that gives you negative 4 minus 0 is negative 4. Okay. So now let me erase this. Now you want to calculate the J. So what you do is you block out the J. Then it's always slant down first. 1 times negative 2 is negative 2 minus 0. So, but remember, J always has, you need to change the sign. So it's negative 2 minus 0. That gives you negative 2, negative and negative 2, right? Is, so basically I show you, it's 1 times negative 2 minus 0 times 0. So that is negative 2. But because the signage, you need to change the signage so it becomes positive 2. So your J is 2. Okay? Now let's, so just remember J, you must always change the sign. Okay. Then when you want to calculate your K, you block out it. Open to my, no, this is, okay. Then you blocked out the K. Okay, you block out K, and you always use slanting down first. So 1 times 4 minus 2 times 0. So that gives you 4 minus 0 is equals to 4. Okay, so you have 4. Okay. So this is the fastest way because you don't have to rewrite it again. You just blocked out 1 I when you're calculating I, blocked out J when you're calculating J, blocked out K when you're calculating K. And earlier I didn't show the workings for the I, so let me just show you the workings for I. So what I did earlier was when I was calculating I, right, I blocked out the I. So it's like that, slanting down first. So it's 2 times negative 2, then minus 0 times 4. So that gives you negative 4 and minus 0. So you get negative 4. So that's how you get negative 4 for I. Okay? So, yeah, so this is basically a quick video to show you the quickest way. Quickest way basically because you don't have to you just basically use your original form like that. You don't have to go and rewrite it again, and just remember you block out I when you're calculating I, block out J when you're calculating J, and just remember J, you must always change the signage. Okay, and then K, you block out K when you're calculating K, and always remember it's always this slant down first, this times this times this. Okay, so it's like 2 times negative 2, then minus slant up, minus this times this, minus 0 times 4. So remember always slant down first, then up, then minus up. And always remember when you're calculating J, right, remember to change the signage for J. Okay. And this answer here, right, is not in the lowest term. So even for vectors, you can put it to, because you are only concerned with the direction, so you can actually just put it to the lowest term. So your direction vector is 2 minus 2, 1, 2. Oh yeah, and also yesterday when I was calculating in yesterday's challenging question, vectors distance between two planes, right? I need to also let you know that because this one is, okay, let me just erase. Okay, I'll go to the next slide first. So yesterday I converted the plane equation (1 minus 3, 2 plus lambda 1, 2, 0 plus mu excuse me, 0, 4 minus 2. This is the plane equation of a plane. I converted this into the R dot N format, right? So I cross this to get the N. Okay, so in my earlier slide I showed you how to cross it fastest way. So this one it was the cross product is equals to 2 minus 2, 1, 2. So the plane equation minus 2, 1, 2 was equals to minus 1. This is when we use this dot with minus 2, 1, 2, we get minus 1, right? Which is 1 times minus 2 plus minus 3 times 1 plus 2 times 2 gives us minus 1. That's why this is minus 1, because this is a point on the plane which will always satisfy this equation for plane. Alright. So remember when you cross two vectors, you get a vector that is normal to the two vectors that you're crossing. So therefore, this negative 2, 1, 2 is normal to the plane. These are all covered in yesterday's video on challenging questions, vectors distance between two planes. And I just wanted to tell you that in the D1 minus, so let me just write this, R dot minus 2, 1, 2 equals negative 1. So R dot negative 2, 1, 2 minus 1. So we were finding so this is actually my R dot negative 2, 1, 2. This is equals to, this is the equation of this middle plane. And then we were finding the equation of the two planes which are 9 units away from this middle plane. Okay, we were finding this equation of this plane and equation of this plane. So we know that this is R dot negative 2, 1, 2, is equals to d. So this is the d is what we wanted to find. So once you can find d, you can find the equation of these two planes. So yesterday when I was applying d1 minus d2 in that video, right, I should be using if I take this as d1, right, so it's negative 1 over mod of negative 2, 1, 2. So yes, what I did was instead of writing negative, I wrote plus 2, 1, 2 because I didn't actually, my handwriting was a bit small, I didn't actually see negative. So actually what you should be using is you should be using the negative 2, 1, 2. Okay, you should be using this negative 2, 1, 2. So minus d over mod of negative 2, 1, 2. In the end, the answer is still the same because the mod of negative 2, 1, 2 is just basically your negative 2 square plus 1 square plus 2 square, which is root of 9, which is 3. So even if you had put plus, it will still be the same answer, still be 3. So in the end, it didn't affect the answer, but just want to let you know that I should be using this negative because I should be using the d over the normal, which is negative 2, 1, 2. Okay, so yeah, if you need to know the background of this d1 minus d2, you can refer to the video, my video titled this vector's distance between two planes. And then my second video was the challenging questions, vectors distance between two planes. And this third video, the main objective of this third video was to show you the quickest way of applying cross product, which I have shown in the earlier slides. But I went on to mention in my yesterday's video that my normal should be negative 2, 1, 2. Okay, all right. So okay, so I'm going to go through more challenging questions on vectors, and I will also go through what does the equation of a line, vector equation of a line, what does it really mean? Because many students actually didn't understand. They know how to form a vector equation of a line, but they didn't know actually what it means. So you subscribe to my channel, and I will cover those in the later lectures. So, okay, bye-bye. Take care.